everything that we do here in synthesis will apply to decomposition. It's just going to be in reverse. Okay? So that's why these two are kind of easy to do, because if you know one, you can figure out the other one. You just flip it. Okay? You just flip it. Okay. Now, so let's get going here, because we'll be doing a little bit of practice. Okay. Let's take a look here. And we did some synthesis the other day. And we know, just reviewing, synthesis are exothermic in nature. And we did basically some elemental synthesis, where you just take two elements, combine them to make their specific compounds. Okay? And we said that there are some special rules. Okay? And one of the special rules we covered was that when you take a metal oxide and you mix it with water, you make a metal hydroxide. Okay? That is the first rule. Or first special situation. This is where you have two compounds come together to form a more complex compound. And so in this case we had magnesium oxide and water give us magnesium hydroxide. Or sodium oxide and water give us sodium hydroxide. There's our first special case, first special situation. Now, second special situation. Alright? A metal chloride, when mixed with oxygen or reacting with oxygen, gives a metal chlorate. A metal chloride and oxygen give us a metal chlorate. Alright, let's take a look at this one. Okay, give me an example of an easy metal chloride.
Magnesium chloride.
Magnesium chloride. What's the formula for magnesium chloride?
MgCl2.
You got it. Okay, MgCl2. We're going to react that with oxygen. Jake, how do I represent oxygen? O2. O2. Okay? Makes a metal chlorate. Well, the chlorate I'm going to make, of course, if I'm using magnesium chloride, the chlorate I'm going to make is magnesium chlorate. And what is the formula? Sawyer, what's the formula for magnesium chlorate?
MgO2. No, MgO.
What's the formula for chlorate?
ClO.
Not ClO2.
ClO2.
ClO3. ClO3. And what's the charge on chlorate? -1. So, and magnesium in this case is +2. So what's the formula for magnesium chlorate?
No,
Nope.
Cl parentheses 2.
It'd be MgClO3 in parentheses 2. Because the magnesium has a +2 charge, the chlorine has a -1 charge. So I'm going to make magnesium chlorate. Now, I've done the correct formulas. My last step is to balance. Okay? I've got one magnesium here, I've got one magnesium here. Alright? I've got two chlorines here. I've got two chlorines here. Problem is I've got 6 oxygens, I've got 2. How do I balance it?
3.
Alright, put a 3 in front of the oxygen. That gives me 6. And I'm balanced. Okay? And I'm balanced. Now, that would be the correct formula, or correct formula equation. Let's pick another metal chloride, something a little different. Let's say potassium chloride. What's the formula for potassium chloride?
KCl2.
What's the charge on potassium?
+1.
+1. 1. What's the charge on chlorine?
A1.
So it's 4 mole.
KCl.
KCl. Plus O2, because that's oxygen. Okay. I'm going to make a metal chlorate. Since my metal is potassium, I'm going to make potassium chlorate. So what's the formula for potassium chloride? Now let's think about this. Potassium has a +1 charge. Chlorate has a -1 charge.
KClO3.
KClO3. So I make my formula KClO3. Now I have to balance. Now I got to do a little trick here because I got 1 for the potassiums. Chlorine is 1, 1. Now the problem is I have 2 oxygens here, I have 3 oxygens here. How am I going to balance a 2 and a 3? What's the number they both go into? 6. So I would put a 3 here, a 2 here,
And a 2 in front of KCl.
and a 2 in front of the KCl. Okay? So now we've got a metal chloride and oxygen. Give us some metal chlorate. Like I said, this is going to be easy for decomposition. Because all the decomposition reaction is the same reaction going in reverse. It's the same rules in reverse. So if you know these rules, you know the decomposition rules, the decomposition situations. Okay? Any questions on this one? Metal chlorides and oxygen always give us a metal chlorate. Okay? A little different one. A non-metal oxide and water give us a ternary acid. A non-metal oxide and water give us a ternary acid. Give me an example of a non-metal oxide.
Sulfur oxide.
Sulfur oxide. You bet. Or just, we'll just say sulfur dioxide. SO2, that would be a non-metal oxide. SO2 would be a non-metal oxide. SO3 would be a non-metal oxide. Okay? And I add water. These are really easy to do. All I do is I just combine them. H2, S, and then how many oxygens do I have? 3. These are actually pretty easy. I made sulfurous acid. Do I need to balance?
No.
No, these things are already balanced. This is probably one of the simplest rules there are. It's one of the few times you can just combine things. So if I took carbon dioxide and water.
CH2O3.
Well, since it's an acid, we always put the hydrogen first. You bet. H2CO3. Carbonic acid. This is what happens when you blow bubbles in your pop or your water. You blow carbon dioxide into your water with your straw, you're actually making carbonic acid. Okay? So, but a non-metal oxide in water just gives us a ternary acid. With this rule, you can just combine. You can just combine them. You don't have to worry about oxidation states. They just kind of work out that way. All right. These last two get a little more complicated. A metal oxide and a non-metal oxide form what we call a ternary salt. Okay? They form what we call a ternary salt. Now, what do we mean by this? Is if I take a metal oxide, give me an example of a metal oxide. which would be, let's say, Na2O. And I'm going to combine it with a non-metal oxide. What do you think? James, what's a good non-metal oxide?
Boron oxide.
What's that?
Boron oxide. Fluorine oxide.
Fluorine oxide? Let's do one of these. Which one do you want to do? SO2 or CO2?
SO2.
SO2. Okay? Now, if we do this, we get a ternary salt. And what do we mean by a ternary salt? Again, what we do is we just combine these two. Na2, SO3. Now, these are special cases where this works. And the reason why this works, it still works out because SO3 is the sulfite polyatomic. And can anybody tell me what is the charge on the sulfite polyatomic? SO3. You have a chart? What's the?
-2.
-2. And sodium is a +1. So when they come together, what should be the formula? And that's what you get. Now, these are always a little bit, you kind of get the idea that all of them are like this. These are the two special situations where you can do that. Okay? They are more the exception than they are the rule. Most of the time you got to worry about oxidation states. Here they just happen to work out. So if I took strontium oxide and combine it with carbon dioxide, what should I get?
SrCO3.
SrCO3. And it does work out because carbonate is a -2, strontium is a +2, and they should come together in a 1-to-1 ratio, which they do. Okay? So that works out. Alright? It just happens to be that way. But that's a special situation. These two kind of work together in that respect. Because actually here, this is a special case of this, because hydrogen here is a metal. So you actually do have a metal oxide and a non-metal oxide coming together. It just happens to be that metal oxide is water. Okay? Another version of this rule is metal oxides and carbon dioxides give us metal carbonates, which is what we have up there. Anytime you take a metal oxide and you mix it with carbon dioxide, you'll always get a metal carbonate. In this case, we have strontium oxide and carbon dioxide gives us strontium carbonate. Okay? So if I took any other, give me another metal oxide, from over on this side. One of you guys over here, give me a metal oxide.
Barium oxide.
Barium oxide. BaO. Okay? Combines with carbon dioxide. So according to this, I should get barium carbonate. Well, BaCO3. So one of the things that you have to understand is these three rules right here kind of fit together. If you look at water being a metal oxide, because hydrogen is being treated as a metal, so really hydrogen is a metal here, so it is a metal oxide. A metal oxide and a non-metal oxide give us a ternary salt. It just happens to be the salt is an acid. And that's what acids are. Acids are salts dissolved in water. They're hydrogen-based salts that are dissolved in water. So these three actually